you still remember your logarithm, which I hope you did, well, negative log of this times this equals to negative log of this plus negative log of this. Well, negative log of this is pH. Negative log of this is POH. So pH plus POH equals to the negative log of this number. Negative log of this number, log 1 equals to 0, log 10 to the negative 14 equals to 14. pH plus POH equals to 14. That's always the case in any aqueous solution. Whenever you're dealing with water solution, pH of the solution plus POH of the solution equals to 14. So if you know pH, you know POH, because they add up to a constant, 14. Okay, so how do we define whether a solution is acidic or basic? If the pH is less than 7, the solution is said to be acidic. If the pH is greater than 7, the solution is said to be basic. If pH equals to 7, well, the solution is said to be neutral. POH, however, is just reversed. Now, this is actually a litmus paper. We can use, well, you hear this term, a litmus test. Litmus test is that when you have litmus paper, when you dip it into an acidic solution, it will give you a pink color. Okay, you will be able to tell, using the litmus paper there, you will be able to tell whether a solution is acidic or basic. And when you dip it in there, pink color, acidic, blue color, basic. Okay, so you use that term these days, and the next presidential campaign has started already. Many people jump in, though some of the people, you look at them, they shouldn't really be in public office, but they jump in anyway. And there are a lot of litmus tests for those people there. And you ask them a question, depending on how they answer the question, well, you know where they stand. Where does it come from? Chemistry. Okay, so chemistry has everything to do with everything that we encounter in their everyday life. So this is how we define acidic and basic solution there. So again, the pH scale. What does the pH number imply? Well, in this case, the lower the pH, the more acidic the solution. Okay? And the higher the pH, the more basic the solution. That's what the pH is all about. Remember, the pH is the negative log of the concentration. The lower the pH, that means negative log, the higher the concentration of the hydronium ion. The higher the pH means the lower the concentration of the hydronium ion concentration there. So the normal range for pH is 0 to 14, but pH could be a negative number. You could have a negative number. Okay. Now, pH equal to 0 is when the concentration of hydronium ion equals to 1 moles per liter. 1 moles per liter, well, that means log 1. Log 1 equal to 0. Okay. So pH can be a negative number there, because if you have a 0.1 molar HCl solution there, for example, the concentration would be 0.1. Well, negative log of 0.1, well, that will give you actually, a positive of pH is going to be a positive one there, because there's a negative sign to begin with. And when the concentration is higher than 1 molar, you could end up with a negative number of the pH solution there. Okay, so the negative number indicates a very acidic solution, very high concentration of hydronium ion. And then larger than 14, that means it's a very basic solution there. So the scale that we need you to remember, for anything that is acidic, pH has to be less than 7. Anything above 7, the pH, anything to be basic, and the pH must be above 7. Right at 7, that's a neutral solution there. Okay, so in this case, neutral solution means you have equal concentration of hydronium ion hydroxide. Each one equals to 1.00 times 10 to the negative 7. 10 to the negative 7 times 10 to the negative 7 equals to 10 to the negative 14. Constant there, Kw. pH plus POH needs to be 14. So the pH for neutral solution would be 7. And then for the acidic solution, that means you have a higher concentration of hydronium ion and then lower concentration of hydroxide ion. So pH is less than 7. Remember definition, negative log. There's a negative sign in front of it. So the concentration-wise, when pH is lower than 7, that means hydronium ion concentration is more than 1.0 times 10 to the negative 7. the other is lower. Hydroxide ion concentration is lower. For basic solution, it's just reversed. Okay, so these are the basic definitions that we want to give you. And how do we do calculations there? Well, once again, how do we classify acid solution, basic solution? These are the pH values that we use to classify solutions into acidic or basic there. So, question we can ask you here. A solution has a hydronium ion concentration of 5.5 times 10 to the negative fifth. What is the pH of the solution? Well, in order to do this calculation, we got to know the definition. Definition of pH, negative log of the hydronium concentration. So pH in this case equals to the negative log of 5.5 times 10 to the negative 5. Okay. Now if you know your logarithm there, and this is a negative log of 5.5 plus negative log of 10 to the negative 5 there. Now, log 10, when you move the exponential number to the front there, so this is basically plus 5, log 10 equals to 1. So basically this is 5 minus log 5.5. And log 5.5, 5 minus log 5.5, you can do that on the calculator there. Now, or if you don't want to go through all this, simply plug this number in your calculator, take the negative log of that number there. That will give you the answer. I thought I had the answer on the slides there. So it's going to be 4 point something. Okay, log 5.5 is probably somewhere around 0.3, 0.4. So 5 minus log 5.5 is going to be 4 point something, meaning this solution is basic, right? Less than 7, supposed to be acidic. We got. Okay, so the significant figures in pH there, and one thing that we do want to point out there, when you talk about the concentration of the hydronium ion, hydroxide ion there, the coefficient, well, we're talking about a relatively low concentration when you use the pH to measure the acidity or basicity there. So if you have one digit, one sigfig in the coefficient, the pH value will carry 1 decimal point, 1 decimal place. If you have 2 sigfig in the coefficient in the concentration, pH value carries 2 decimal places. Okay, so that's something that you want to pay attention to, and you have to watch for the sigfig when you deal with the any measurements in chemistry and physics there. Then you have to pay attention to the sigfigs there. So that's a relationship there, and then we can ask you to do questions there. If we give you the hydronium ion concentration, we ask you the pH. But if we give you the pH, we also need you to be able to figure out the concentration. So this is the reverse. pH is 6.64. What is the concentration for the molarity of this solution? Well, if pH is 6.64, oops. X is what we're asking you there. So inverse log of negative 6.64, or 10 to the negative 6.64 power, that will give you the answer. Plug in that number in the calculator there, and you should end up with an answer there. And it's always going to be coefficient times 10 to the whatever the power. Okay, so the calculations that we want you to be able to do here is that if we have